Okay, this is day 2, section 2, and this will last until 8:30. For your information, day 3 tomorrow and the day 4 the day after tomorrow, the material is currently under revision, and it will be made available on the Google Classroom by 3 p.m. tomorrow. Because the Stata 18 has some user interface changes, so I need to revise the teaching material. So please be patient. So correlations. Um, it measures the strengths of relationship among several different variables. And in our exercise, we want to see the strength of relationship between price and the mile per gallon. Um, we want to check whether higher the price, better the mile per gallon or not, or vice versa. Higher the price, worse the miles per gallon. We don't know. And on top of that, we want to um, measure the correlation for domestic cars and the foreign cars separately. And we're going to use we keep using auto DTA. Probably right now you are using um, the census data. So please import or please open auto.dta. Please open auto.dta. And after that, you go to statistics, summaries, summary descriptive, and the correlations and covariances. Statistics, summaries, correlations. Statistics, summaries, then correlations and covariances, and the pop-up window will appear. First, please open the auto.dta. Okay, good. Then the next step is in the main tab, you choose price and mile per gallon first. In the main tab, you choose price. Where's price? On top. Price and the mile per gallon. And the next, you go to the buy, if, and the in tab. And put check mark on repeat and select foreign. Hold on before hitting submit. Up to here, please do so. Okay, then please hit submit, and look at the main window. You will see two simple 2x2 matrix, and the result is pretty much straightforward. Price and price correlation apparently is 1 mile per gallon, 1. And price and mile per gallon for domestic cars, the higher the price, the worse the mile per gallon. The coefficient is minus 0.5. Similarly, for foreign cars, the coefficient was minus 0.6. That means domestic cars, the higher the price, the worse the mile per gallon, but the effect is stronger in case of foreign car. The higher the price, the worse the mile per gallon, more severely as compared with domestic cars. So maybe this is because high price cars are heavier, bigger, and um, it has many options. Then the mile per gallon naturally goes down. Okay, so we have seen this, right? Strong negative correlations. Correlation coefficient ranges from 1 to -1. So -1 is totally negative correlation. 0.5 is somewhat strong negative correlations. And correlation is a powerful tool. However, there are some pitfalls. Here, we combine the price with mile per gallon. However, as I guessed, um, there's no direct relationship between price and mile per gallon, but the price has relationship with car weight or length or size. And um, due to the heavy weight, mile per gallon gets worse. So uh, we cannot simply say higher the price, worse mile per gallon. It is uh, it is misleading. So in this case, the price may be related to the weight, or weight is related to the price, and um, due to the weight, the mile per gallon gets worse. So it is not always correct that you um, conclude that there's a direct relationship, direct correlation between two variables. There may be some hidden mediator or co-founders. For example, here, ice cream sales is high when the rate of drowning in the pool is highest. It means ice cream sales causes drowning, or vice versa. It's wrong, correct? The real story is heat wave, which is hidden, unseen, and confounding. And a heat wave is affecting both ice cream sales and the rate of drowning. Second, the correlation shows two-way relation. It is not reason versus, the cause versus result. So you cannot prove which one is the cause and which one is the result by using correlation analysis. In reality, proving causal relationship, this is the cause, this is the result. Proving cause and result relationship is very, very difficult, even if you use the advanced statistical technique. So, by using correlation, causal inference is impossible. So, you are not supposed to conclude this is cause and this is result because these two or multiple the variable have high correlation. And the correlation between number of Nobel Prize and the chocolate consumption. Okay, the x axis is chocolate consumption, and the y-axis is number of the Nobel Prize. And the Switzerland has highest chocolate consumption kilogram per year per capita, and the highest number of Nobel Prize per 10 million population. And it seems there's very high correlation. Low chocolate consumption results in low Nobel Prize, which is absurd. However, this kind of relationship occasionally emerges. But you shouldn't, apparently in this case, you shouldn't you shouldn't assume chocolate consumption and the Nobel Prize has a relationship. There must be some hidden and complicated um, chain of the relationships. Okay, so next we go to the simple linear regression. ordinary least square method. I think you are very familiar with simple linear regression. Um, it has independent variable and a dependent variable. And you can set only one dependent variable, not only in case of the simple linear regression, but it is also the case in case of the multiple regression. So you can set only one dependent variable. But on day 4, we will see the structural equation modeling, which is the much advanced model, statistical model. And SEM can handle having multiple dependent variable within the model. But you will see that model on day 4. So let's focus on the simple regression. And the correlation and the regressions are based on the different theoretical foundations. In case of simple regression, just one independent variable, then correlation coefficient and the R square may show very similar result. However, they shouldn't be handled or used interchangeably. So if your purpose is finding the regression line, you use regression. If you want to see the strengths of relationship, then you use correlation. So please do not mix them up. And in case of multiple regression, we will check in more detail, but multiple regression sometimes is very tricky, and there's a multicollinearity problem. And there are many variety of regression models. Let me show the example. Within the data, if you choose statistics and, for example, ordinal outcomes, then order the logistic regression, order the probability regression, and the binary outcome, logistic regression, probability regression. So there are many, many different variety or the types of regressions, and you need to select the appropriate regression model. Simple OLS, simple regression model assume the linear number. I will talk about the type of measures at the end of today's session, but the simple regression model is appropriate only for the continuous number. You cannot use simple regression for regressing apple, orange, and banana. You cannot do that. Okay, so let's do the simple regression. Um, of course, you can run the simple regression or even multiple regression on Excel. However, the Stata gives you richer the indicators and the coefficients available as a result of regression. So, the if you just casually run the regression. Excel is good enough. However, if you are serious, um, I recommend that you use Stata for regression. Okay, so I believe you are still opening Auto DTA, and um, we go to statistics, linear model, and the linear regression. Simple statistics, linear, and linear regression, and this pop-up will appear. So please do so. Statistics, linear, and linear regression. Okay. Then let's put mile per gallon for dependent variable and just one independent variable, weight. Mile per gallon for dependent and the weight for independent variable. If you choose multiple independent variable, it becomes multiple regression, as you know. Okay, this is simple. And let's submit and see the result. It's your turn. Okay. Then you will see the result like this. Regress, mile per gallon, and the weight, and the source, SSDF, MS, number of observation, F probability, R squared, adjusted R squared, root MSE. It looks weird. It must look like this. My model went wrong. Somebody got it right like this.
Yes, we got it
Yes.
right.
You got it right. Okay, I got it wrong. Something went wrong. Linear regression. Submit. Something's wrong on my side.
Professor exchanged dependent and independent variable is exchanged.
Oh. Weight and mile per gallon. Like this.
No, Professor, it's the other way.
The other way, right?
Yeah.
Yes.
It's
And then
otherwise. Yeah.
you need to maximize your screen so that you can be able to see the aligned.
Mm-hmm. Okay. So, since you got it right, I'll go ahead. Um, this part, the sum of square, degree of freedom, and the mean square, this part is just the same with one way and over output. And here we have hypothesis hypothesis that all coefficient other than constants are zero. And since the significant is 0.00, so the null hypothesis was rejected, and we can confirm that the coefficients are not zero. And I believe you are pretty much familiar with R squared. The better the R squared, the better the fit. And the 0.65, generally it's considered as a good fit. However, um, actually, uh, from scientific field to field, the accepted level of R squared differs a lot. In the natural science, the R squared of 0.65 may be considered as poor. However, in the social science, 0.65 is generally very good. Even in the human behavioral science, even zero point 0.4 or 0.3 may be okay number. And we'll talk about the adjusted R squared in case of multiple regression. In case of the simple regression, one independent variable, adjusted R squared does not have a lot of meaning. And if you see the coefficient, weight has slightly negative slope. Probably you know um, the regression has the slope. Regression has slope and the constant. And in this case, since weight has the negative number, the slope is downward, downward. So the higher the price, the uh, the lower, sorry, the weight has a negative effect on mile per gallon. Sorry, not price, mile per gallon. Okay, so that's it for simple regression. And let's go to the multiple regression, mile per gallon, and the weight and the following. So in this case, we have two independent variables, mile per gallon and the following, and the uh, dependent variable will be weight. So this is wrong, correct? So mile per gallon and the following, and the dependent variable will be weight. This is not right. So let me do so. Let me do that. Not this one. Um, statistics, linear, regression, and this time I won't make mistake. Dependent variable weight, independent variable mile per gallon, and the following. Actually, foreign is 10, 10, the variable. So to be strict, we need to treat this foreign number as a binary value. But for simplicity, I will use it as a I will treat it as a continuous value here. I hope it works. It doesn't work. What is the right answer? Mile per gallon versus pouring and weight. Bad. I'm supposed to get this kind of result. Could somebody help me out?
Yes, Professor, we got this answer.
Okay. How did you arrange this window? Regress, linear regression, correct?
Yes.
Yes, Professor.
And
Regress,
Dependent
MTG.
variable MPG and independent variable weight and foreign.
weight and foreign. Okay.
Yeah.
Yes.
I keep getting something wrong.
Professor, it's same, like, it's only that your window, like you must maximize that
Yeah,
starter so that you can be able to get it aligned. It's correct. It's only that alignment of your output.
Okay.
Yes.
Oh, yeah, it's
correct.
okay.
It's correct, Professor.
Yeah, that's okay. It's rounded here.
Just maximize your window and then you run again. You'll get it.
Yeah. Okay.
Run the second time. And then
Yeah. Okay. I got it right.
Nice.
So, this time, since we are running the multiple regression, we do care about adjusted R squared instead of a simple R squared. And the R squared, still, it is in good shape, slightly improved from the one variable regression case, which is here we have 0.6532. And previously, it was 0.6467. So by adding the foreign, the adjusted R square improved a little bit. And weight has a slightly negative slope, as we have seen in the case of simple regression. And the foreign has the clearly negative slope of minus 1.65. That is because we called it that the foreign car is 0 and the domestic car is 1. So the lower the value, that means a foreign car. If the car is foreign, then the mile per gallon tends to be better. But this is a kind of compromise because the foreign variable is 0, 1 variable. So we need to treat our foreign value as 0, 1 value, not continuous the number like weight. And if you want to do that strictly, then the method will be to put I dot before foreign. This is beyond the scope of current session. However, if you do that, then you will see a somewhat different result. This is the binomial 1, 0 value expression. Okay, but anyway, we'll talk about the multicollinearity next. Multicollinearity is a problematic symptom when you run the multiple regression. And the Stata has the functionality of checking whether multicollinearity is present or not. And the process is after running, let me run the original regression. Okay, after running multiple regression, you go to linear regression, specification test, etc. Okay, so statistic, linear, and where's the specification? Here, yeah, regression diagnostics. The menus thread changed slightly in version 18. So it is not exactly the same. However, I found it. So statistics, linear regression, regression diagnostics, and the specification test, etc. Then you will find the variance inflation factor, VIF, variance inflation factor in this. Here we go, VIF. And we just click OK and see the VIF evaluation. So it's your turn. Again, you go to statistics, linear, regression diagnostics, specific tests, and you choose variance inflation factor, VIF. It's your turn. Okay, good. Then let's click on OK or submit. Okay, I'll click on submit. Then start BIF, and we see 1.54 BIF. And if BIF is greater than 10 here, if BIF is greater than 10, then multicollinearity effect is high. Some researchers are stricter and consider the risk of multicollinearity if BIF is greater than 5. However, in this case, BIF is just 1.54, so we are safe. And whenever you run the multiple regression, I recommend that you run the BIF check after running the multiple regression. Okay, that's all for today. And I will go back to the discussion of the variable type. Let's take a small 10-second break. You stretch. I will change the topic. Okay. As I mentioned in the section of simple regression model, you cannot regress apple, orange, and banana. You can regress only when the measurement is ratio or to the maximum compromise interval. Using regression for ordinal measure may be risky. Okay, let's have the example. Nominal or categorical. Categorical data is like your eye color, black, brown, sapphire, gold, blue, whatever. But you cannot make it which one is bigger than something. They are just different. And the ordinal measure, probably if you conduct the questionnaire survey, then the answer may come strongly disagree, agree, strongly agree, neutral. Of course, strongly disagree is worse than disagree, and disagree is worse than neutral. So there is some order. However, can you say the difference between strongly agree and agree and neutral, the distance is the same? We cannot guarantee. There is some order, however, the distance is not guaranteed. So this is ordinal measure. Interval measure and the ratio measure, they are better quality measure. Temperature is interval. Temperature in terms of Celsius or Fahrenheit, there's a 0 degree. However, it is arbitrary. And also, can you say, for example, 20 degrees Celsius times 2 makes 40 degrees Celsius? Does it make sense? No. So, the temperature is interval. Of course, the difference between 10 degrees Celsius and 20 degrees Celsius and 20 degrees Celsius and 30 degrees Celsius. 10 degrees of Celsius difference makes sense. So interval is better measurement as compared with ordinal measurement. Ratio, for example, height, the okay, height or altitude, okay, then sea level is zero. Sea level is zero. And the mountain 500 meters high or the deep sea minus 1,000 meters the deep, you can calculate the ratio. 1,000 meters high times 2 makes 2,000 meters high. It makes sense. However, in case of interval, 10 degrees Celsius times 2 makes 20 degrees Celsius doesn't make sense. So for nominal or categorical data, you can just say it is equal, it is the same or different. For ordinal data, you can say which is better or which is greater, which is smaller, which is worse. But you cannot add or you cannot subtract. For interval data, you can make addition or subtraction. However, you cannot multiply. For ratio, magnitude, amount, you can multiply or divide on top of addition, subtraction, or comparison, equal or non-equal. And here, if you want to see the detail, you can visit the UCLA website. However, this page is the description of appropriate statistical method. For example, if the number of dependent variable is 1, dependent variable 1, and one population, no independent variable, then you can conduct one sample t-test or one sample median binomial test. If you have one independent variable with 2 levels of independent groups, then you can conduct 2 independent sample t-tests, chi-square test, Fisher's exact test. And if you have one independent variable with 2 or more levels, then you can conduct one-way ANOVA, as we learned, or Kraskell-Wallis. So there are a lot of the tests which are unfamiliar to you. However, if you really want to choose the most appropriate test type, then you can refer to this kind of table and decide what kind of analysis type is most appropriate for your purpose and for your given data type. And here, today, we talked about one independent variable with two levels, independent groups, interval or normal measure. Then we conducted the two-group t-test together with f-test as a preparation. And for two or more levels of groups, we conducted one-way ANOVA. We already done it. And paired test, we didn't do that, but we understood what they are. And correlation, one interval independent variable, then we can conduct correlation or simple linear regression. And if we have one or more independent variable and one or more categorical independent variable, then multiple regression is possible. However, if you deal with categorical independent variable, then you cannot run linear regression, but you need to run the categorical regression. As we have seen in this statistics menu, we have categorical outcomes and multinomial logistics, multinomial probit. So there are several choices of regression models which is suitable for categorical data or ordinal data, which ordinal data refers to something like the questionnaire survey. Order the logistics, order the probit. These regression might be better. Of course, as a compromise, you can use linear regression. However, to be strict, it is better that you use ordinal regression for the questionnaire survey or something. And for day 3 or 4, I'm not sure, we will examine factor analysis, which is a more advanced statistical technique. So what I wanted to address with these pages is basically I want you to be aware of the difference among these level of measurement. Whether you are dealing with ordinal measurement, interval measurement, or ratio measurement. And if you visit the page like this, this is the website. Or this is the UCLA website. And UCLA has recommended more detailed recommendation. For example, let me see, one-way ANOVA, One-way ANOVA technique is available on SAS, STATA, SPSS, and R. Some technique may not be available in a certain software package, but here we have the probably within UCLA they have a link here. Let's try one-way ANOVA STATA. Okay, so they have very much detailed explanation here. On top of that, let me share with you how to get the manual of STATA. You go to help, and the PDF documentation. Then PDF document will open. And this is the STATA manual, STATA index, and there are about 20 or 20 something different the STATA manual PDFs. So you have very extensive the manual, and let's search for example, one-way ANOVA. Then you can choose the magnifier here to find one-way ANOVA, and then I will type one-way ANOVA. Then here, large one-way ANOVA random effect and reliability. This is a little bit far advanced. So let's click next. Large one-way ANOVA again. Okay, let's go next. One-way ANOVA L one-way R. R means R language. So this is not what I'm looking for. Oops. Maybe this one has something. So let me click on this L one-way. Then I jump to the large one-way ANOVA menu. ANOVA maneuver, large one-way ANOVA. This is not what we did. Then let me go back to the contents and simply search for ANOVA. ANOVA and related. Okay, looks good. Okay, ANOVA and related analysis of variance and covariance. This is probably this is exactly what we did. And the first quick start menu will show you the command line ANOVA YA, the model of Y for factor A. But this is a little bit difficult for you to understand instantaneously. But here you find the menu statistics, linear, ANOVA maneuver, analysis of variance and covariance. So here you can understand where you can find the graphical interface instead of typing the command. So statistics, linear, ANOVA. This is exactly what we did today. And the syntax, there are a lot of the options. And of course, you can type in the options in the command line. However, for the beginner, it may be difficult. Therefore, here you have example. So you can study how to use one-way ANOVA for this example. You can, by looking at the example, you can learn how to run one-way ANOVA. And it has the sample data. If you install the if you fully install the Stata 18, the sample data is already on your device, or it is accessible through web connection. So here we can see how to run ANOVA in greater detail together with sample data that you can play. And here we have explanation about how to read this table. See regress for explanation on how to read this table. So there are lots of the material here. Two-way ANOVA is something that we haven't covered, but we have two-way ANOVA, three-way ANOVA, which is much more complicated model. So similarly, we can search for example, for day 4, SEM. Latent class model. We'll deal with latent class model on day 4. There are lots of introduction. We will not cover everything on day 4. However, SEM is one of very powerful and commonly used the statistical model. So if you come up with any question, you can go to help PDF documentation, then you can access the rich document. Okay. Let me show you the preview of the intermediate module now. Since we have about 25 minutes. One moment. From tomorrow, for day 3 and day 4, we get into the intermediate level of statistical model. And the content in the intermediate module deal with techniques not covered by applied statistics or the equivalent courses. So you need to study by yourself for the theoretical foundation and how to interpret the result. I will briefly explain how to use it and how to interpret the result. However, I cannot fully explain the how each technique works and what they mean exactly. And here we have advanced use of linear regression, stepwise or hierarchical method. Stepwise method is very useful. For example, if you collect 20 variables, then you may not have very good idea which one should be dependent variable and which candidates of independent variable can be good good predictor of dependent variable. Stepwise regression lets you automatically select the best possible independent variable out of the group of candidates. So stepwise is very good. And the exploratory factor analysis, if you have a lot of data, then you may want to see the structure of the data. And the EFA gets you some idea how the data is structured and how each variables are related to each other beyond the scope of correlation. And the cluster analysis is good for categorical data. Categorical data is not, for categorical data, it is not possible that you regress or you the measure correlation. Sometimes it is possible, sometimes it is not. Cluster analysis helps you evaluate the closeness or the difference of the categorical data. And the reliability test, I will not explain in the great detail today, but the Cronbach's alpha is one of the important measurement when you build the scale. For example, you conduct the questionnaire survey, and you want to know whether you measured one single concept or not. Cronbach's alpha helps you determine whether you measured one single dimension or multiple dimensions. So linear regression and factor analysis, we see a lot of models which will take 2 days to complete. And the cluster analysis. Cluster analysis shows you the tree-like the graph. This is called the dendrogram. So this helps you categorize the categorical or nominal data. And the cluster analysis and also the Cronbach's alpha. And the final module is the multivariate analysis, SEM, structure equation modeling, and the multi-level structure equation modeling. To fully understand the theory of SEM will be very, very challenging. However, as a user, you can use the SEM model. And as I mentioned, this is multiple regression model graphically designed under SEM. And you can put another dependent variable in case of SEM. And this kind of the more the complicated or more advanced analysis is possible. So we will go through this kind of material from tomorrow, and we start from the stepwise the regression. Okay, so this is the question time. Whatever thing you have in mind, I will be mostly happy to answer your question. Yes, Yedje?
It's excuse me, Professor. I have one question regarding to the exam. So, so can we choose between to pass as a beginner or intermediate, or just to be?
The final exam is just one single module, and I will not challenge you to deeply dive into the intermediate level of model, but the majority of the final exam contents will be from basic modules.
Oh, okay, thank you. Okay, good.
And the requirement, there are two requirements. First, you need to be registered to the OAA roster. And the second requirement is your participation more than 50%. That is, in total, we have the 12 hours of session. So your attendance of more than 6 hours is required. And by way of using the Zoom Zoom log, I can measure how many minutes you participated online. So for those who were online in total of more than 6 hours, will be eligible for final exam.
Sensei,
Yes.
not exactly a question, just like in the help menu, you said that there is a PDF documentation. I went there and I found that the PDF documentation that I downloaded is much smaller. Maybe Maybe I'm mistaken. I thought that I think that your one is much bigger. Like it has so many pages, more than 3,000, if I'm not wrong. So can you share that? Can you share your file to us?
Yeah, as far as you have the valid valid STATA license, I think you automatically have the PDF file already downloaded. Otherwise, I recommend you to go to, sorry, not this one. I recommend you to go to the help and check for updates. Don't do that right now. Check for updates will the download all possible files you can download.
Okay, Sensei, can you show us the file named i.pdf?
I.period. Okay.
I.pdf, you just opened a bit earlier.
Yes. This is I.period. Total of 308 pages.
Okay. Sensei, then it's okay.
Okay?
And now it's okay. Thank you.
Okay. Other questions? Okay, so please remember that here we have the history, and also I've been running the log, so I can view the log file. Then everything I recorded so far is on this log file, including the mistakes. Okay, and similar to what we did yesterday, we can choose the table like this and copy as picture and paste. To let's have one line and paste as a picture. Then it looks nice. And also we talked about cropping. Crop and make it small to fit into the nice place. So when you write your thesis or research paper, it is easy for you to paste the table. So you can do this either directly from the main window of Stata or from the log file. This is log file and this is main window. From main window, you can do the same thing here and copy picture. HTML normally doesn't work very well. So I recommend copy as picture. And also, sometimes you may want to how can I say, the store these number into Excel file. It is a little bit tricky especially if you are using SMCL log file. So let's do some experiments. I will close SMCL file temporarily, and I will open the new log file under the format of log. And let me try to run the regression so that I can record the result in the log .log file. View. I'm not 100% sure. However, I think this .log format is more compatible with the Excel import. And for tomorrow, let me try to search for the better way to store the result into Excel cells. Because if you just copy and paste the data to Excel, then it will become extremely messy. Let me try doing that. If you paste, then it will become like this. It's not what you want, correct? So the pasting each number neatly fit into each cell is a little bit tricky. So I will try to find a better way for the next day, tomorrow. Okay. Any other comments, suggestions, or the request? Yes, Yadji?
Professor, I just want to ask again one more question about regarding to the, you said that to one of the criteria to get to the exam, we need to have at least 2 hours, yes? On the session.
6 hours.
Sorry, my fault. Yeah, 6 hours. But how do you measure that during this Zoom? So you look at based on how we answer to your survey, yes, to your questions when you just put it.
No. It is simply the measurement of connection time, and the Zoom has the capability of measuring the connection time as a statistics. So based on the statistics, I calculated the total number of connection time.
Oh, okay. Sorry. Thank you.
Unless you have other remaining questions, today's session is over.
Excuse me, Professor.
Yes.
Regarding registration at OAA, what should we do, or we are already registered for this course?
If you registered, then you are all set. The registration period is already over, and more than 50 people registered to this course. with the OAA, not directly with me.
Okay, okay. Thank you.
Okay. Okay, then have a nice evening, and let's get together tomorrow at 5 p.m. And I will prepare the revised intermediate module by 3 p.m. tomorrow. So please check back on the Google Classroom tomorrow after 3 p.m. and download the zip file. Thank you.
Thank you, Professor.
Thank you, Professor.
Thank you, Professor.
Thank you,
Professor.
Thank you so much.
Thank you.
Have a nice evening. ありがとうございます。Thank you.
Thank you, Professor.
Thank you.
Thank you, Professor.
Hello. Thank you, Professor.
Thank you.
Thank you, Professor.
Thank you. See you.